Hi, I'm Jonathan Glesser. This is a translation challenge problem. Given the translation of a point, in this video we will show how to compute the effect of that translation and how to apply that translation to other points. We will finish with a practical application to video editing. Most of what we discuss in this video will extend to higher dimensions or to the real number line, but we will confine our discussion to the plane. Our second assumption is that the only rigid motions we will consider in this video are translations. We will not consider, for example, reflections or rotations. We start with 2 points and the assumption that one of the points has been translated to the other as indicated by the arrow in the diagram. We will use vector notation to describe this translation. If we focus on just the x-coordinate, we see that it changes from 1 to 4 at an increase of 3. The y-coordinate changes from 5 to 1, a decrease of 4. Therefore, we indicate the shift by the vector 3, -4. More generally, if we translate from point x1, y1 to point x2, y2, then the change in the x-coordinate is given by x2 minus x1, and the change in the y-coordinate is given by y2 minus y1. The advantage to using vectors to represent translations is that vectors describe a shift that does not depend on the starting point. This means that if we change our starting point from 1, 5 to say 3, 6, then the vector representing the same translation is the same. Increasing the x-coordinate by 3 and the y-coordinate by -4 yields the translated point 6, 2. On the goal side, we gave our example problem that we now solve. First, we are given a point translated from -2, 5 to 1, 9. The x-coordinate increases by 3 while the y-coordinate increases by 4. Therefore, the translation vector is 3, 4. As every other point is translated by the same vector, we can increase the x-coordinate of -7, 2 by 3 and the y-coordinate by 4, yielding the point -4, 6. An important application of this technique is translating images when video editing. For example, I am recording this video in Camtasia. Say I wanted to take this image of my dog and animate it moving to the opposite corner of the screen. Under the hood, Camtasia is representing the picture as a collection of points. It then determines the translation vector and simultaneously applies that vector to each of the points. By itself, this would actually just make the picture appear in the lower right. To get the animation effect, Camtasia repeatedly scales the translation vector by a parameter whose values lie between 0 and 1. When the parameter is 0, the scaled translation vector is 0, so this corresponds to the starting image. When the parameter is 1, you get the full translation vector corresponding to the final image. For the values between 0 and 1, you get various copies of the image. Put together, this creates the illusion of motion, i.e. animation. Thank you.